This this MachTach came back from a customer. He assembled it. He did a real nice job. The soldering is real good on it, but he says that it's unstable. It's not giving solid readings. So I have it hooked up here to my lathe. I'm going to test first the IR sensor. He's using actually a gear tooth sensor, but we're going to make sure that it works with the IR sensor first. So I've got the little IR sensor clipped on to my tool post here, and it's about 0.15 inches away from this little piece of pipe I have here with 4 reflective patches on it. So we'll go ahead and start this up. There's a MachTach already installed in the lathe here, and so you can see it's reading 447 there and 447 there. There's a little bit of variance there, but that's normal for a MachTach. Sometimes you'll get plus or minus 1 RPM a reading. We'll go ahead and crank up the speed here. So we got 859, 859. So let me go ahead and shut this down. So it appears that this MachTach is stable on my setup here. So the question is, why is this customer having problems? And what I've seen in the past is some VFDs, which I think this person is using, can put out a tremendous amount of electrical noise, and that can cause misreadings on the MachTach. So what I'm going to do is I'm going to finish testing this MachTach with the gear tooth sensor and also a proximity, inductive proximity sensor that the customer supplied, and see if I can get it to work with that. I have never tried that, but we'll see if that works. And if everything looks stable, then I'm going to assume he's got some VFD noise problems, and I'll send a filter when I return this to him. So I'm going to continue this video later here after I change the setup to another sensor. This is the gear tooth sensor setup. What I've done here is I've taken the customer's gear tooth sensor and clamped it onto the tool post via a actual tool there. I just have a little spring clamp. The distance between the face of the sensor and the gear is not super critical, but I've probably got about 1/8 of an inch there. That's adequate. This is a 60 tooth gear. I think the customer is using a 76 tooth gear, but I don't happen to have that gear. But this should adequately demonstrate that the gear tooth sensor is working. So let's go ahead and start the lathe up. Here's our internal tachometer. We can see that it's running at 532, and if we go up and look at the customer's tachometer, it's also running at 532 plus or minus an RPM. It looks to be quite steady to me. So again, whatever problem this customer is having is probably related to VFD noise. This lathe has a VFD on it, and the MachTach has VFD filtering, noise filtering on it, but it's possible in some severe cases that it's not adequate. Let's go ahead and crank this up and see what happens at higher RPM. Looks very steady. Looks like a good tachometer module and a good gear tooth sensor. Customer that sent this MachTach had their gear tooth sensor configured such that the sensor faced perpendicular to the board, so that would be this way. And the diagram they showed me showed that they wanted to have the sensor mounted in the same plane as the gear, so it'd be like this configuration. In order to do that, you have to bend the sensor leads and mount the sensor in the end of the housing, which they had not done. So I went ahead and put together this sensor and housing such that they can mount this in the same plane as the gear. And now I'm going to go ahead and test this setup here, make sure it works before we ship it back to them. So I've gone ahead and spring clamped the sensor in place where it's pointing at the gear teeth in the same plane as the gear. This is the one of two ways that these sensor housings can be assembled. The other way is with the gear housing in the same plane as the axle of the gear. So we're going to go ahead and start this one up, and I think it'll work just fine. Okay, so we have 378 RPM, and if you look up here, we have 378 RPM. Again, this is the MachTach that the customer assembled. I'm going to go ahead and crank up the speed here. So we see 859 on the RPM, and it's reasonably steady. So we'll go ahead and, just as a demonstration that this gear tooth sensor works at low RPMs, we'll go ahead and run this real low and see how that works. Let's see here. This lathe has got a VFD on here, so we can run this pretty slow. Now there's not much torque at this speed, but when you change the belts you can get more torque out of it too. Okay, so that's pretty slow right there. And we see it's 33 RPM. So this gear tooth sensor seems to be working just fine.